Hello everyone, welcome to MK Projects. So today let's talk about buck converters. Buck converters are DC to DC switch mode power supplies which are used to step down a higher DC voltage to a lower DC voltage. So like let's say if you want a regulated 9 volt supply from a 12 volt supply, then it will be wise to use a buck converter. Basically it comprises of a switching transistor, a diode, an inductor, and an output capacitor. This is the basic schematics with the input going here on the output across the capacitor. So switching is controlled by a PWM signal from either an IC or a microcontroller. So let's look at the on state. So when high pass is applied to the transistor, current will flow from the power supply through the switch and through the inductor and through to the capacitor and to the load. So the capacitor begins charging, but the inductor, since it does not permit sudden changes in current, it stores some of the energy, while the diode D, which is also a switch, is reverse biased and therefore it does not conduct. So when the transistor is off, since the energy stored in the inductor, there's only one path for it to go, and that's through the road, as well as the energy stored in the capacitor. It has to go through the road and then it has to circle back through the diode D1. So the capacitor C ensures that the voltage across the road remains fairly steady, while the inductor ensures that there is a continuous supply of current even when the transistor is off. So the output voltage is determined by the duty cycle and the input DC voltage, with the Vout given by the formula DAGE. So basically, if you have a duty cycle of 50% and an input of 12 volts, then the output is 6 volts, and so forth. With the duty cycle being the value of the duration that the transistor is on over the overall duration during the off and on time. So that's all. Please like, share, and subscribe for more missing projects. I'll see you next time. Goodbye.